Today is day 2 of my pre-MBA preparation series on this channel. In this series, I'm learning complex MBA topics, making notes on it and sharing it with you every single day till I join my B school. Also, if you're on the same boat as me, join me in this journey, subscribe, and let's prepare for MBA together. So, if you haven't been following, we have already finished 2 lectures of this particular course, which is Analytics for Business Problem Solving. Link in description if you want to get started ASAP. It's a free course by IIM Ahmedabad. Anyways, so we've completed 2 lectures now, and we are on the third lecture. I'm on the third lecture right now. I've finished the third lecture, and let me tell you, it has been a very difficult lecture to understand and internalize for me. It has taken me a lot of time to go through this. So in this video, I'm going to explain all of what I've learned in a very compact manner. I advise you as a friend that you watch this video till the end first, make notes yourself, and then you can go and watch the third lecture of this particular course, because otherwise you will spend a lot of time which I spent just researching on various things, on various topics, and it just took me a lot of time to actually understand it. Okay, so let's start at the third lecture. This lecture was delivered to us by Professor Tathagat Bandyopadhyay, and as you know, the first 2 lectures were delivered to us by Mr. Arindam, I think Arindam or Nirban. Arindam Banerjee. So he was a fantastic professor. He taught in a very fantabulous manner. He kept me engaged. But Mr. Tathagat, he whatever he taught was fantastic, but not as engaging as Mr. Arindam was. But in any case, there are different flavors of teachers. We have to love all of them so we can get all the knowledge out from them, right? So let's start with this lecture. This lecture was all about the basics of statistics. It was all about why data is important and what kind of data can we get, how do we use it, etc. Okay. So the first step is understanding what kind of data do we really have. And in that, the first thing that we learned, or I learned, was scales of measurement. That is the different kinds of data. The first kind of data, there are actually 2 categories of data. First one is qualitative data or categorical data. The second one is numerical data or quantitative data. Okay, so there are these 2 kinds of data, and they have 2 subparts each. So there are 2 scales, which is nominal and ordinal. These are 2 types of categorical data, and the other 2 are interval and ratio. These are 2 types of quantitative or numerical data. Now, what's the difference? What are the definitions? Let's go into that. The first thing is nominal. Nominal data is basically categorical data with no info about the order. So for example, gender, male, female, transgender, etc. These are genders, but there's no particular order to it, right? Inherently, all of these particular categories have the same value to it. The next one is ordinal data, which is about order. We can remember it by this, ordinal and order. Okay, so this has inherent order to it. For example, rating. A rating can be a good rating, a medium rating, and a bad rating. So that's about order. There's an inherent order to it, even though it's just words. It's not numerics. Okay, numerical data is later. When we go into interval and ratio data, these are numerical data. But ordinal is not numeric. It's just words with an inherent order to it. Okay, we can also say income levels: high, medium, low; temperature: hot, medium, cold. So these are all very ordinal data. Now let's go to intervals. Intervals is the definition of this is naturally numerical data with inherent order to it, having equal spacing between the points. So between 1 and 2, there's equal space. But here, the important thing over here is 0 is arbitrary. Okay, that's the most important thing. Now, what do we mean? Concentrate carefully, because I took a lot of time to understand this. When we say 0 is arbitrary, it means that the 0 in this particular scale doesn't really mean something. For example, in the Fahrenheit scale, if we say it's 0 degree Fahrenheit, we are not saying that there is no temperature there, right? Inherently, 0 should mean that there's nothing there. But 0 Fahrenheit is not no temperature. It's a very cold temperature. As opposed to this, 0 degree Kelvin is called no temperature. It's the lowest temperature possible. So we are saying it's no temperature. So that's not interval, that comes inside ratio. Okay, so in interval, It scales where 0 is arbitrary, it's not real, it can change, it basically does not have a real meaning. Okay, now if we go to ratio is about naturally numerical data with inherent order having equal spacing between points. So till here it's the same definition to interval, but what changes is 0 is meaningful and absolute. Okay, so 0 is meaningful and absolute, remember that. Examples: weight, height, where we can say 0 weight means there's literally no weight. Height, 0 height means literally no height. That's not the case when it comes to credit score. 0 credit score, we can't even achieve that. Okay, but that's what it means. One is arbitrary and one is absolute and meaningful. Now let's go to what does the scale of measurement really indicate to us, because this is very important. When we have data and we know the scale, why are we even considering this? Why are we even looking at the scale? It's because this gives us some certain information and certain context to it. The context is, first, it gives us the amount of info contained in the data. So a particular kind of data shows us how much info do we get from a particular class of data. So when we say, for example, that there's nominal data, we can understand that, okay, we won't get any info about the order from this. We will get only inherent values, which is equal in value. So we can get something like male and female, but there's nothing else to it. So very less information. As opposed to this, when we talk about ordinal, we also get the information that there's an inherent order to it, right? So it's amount of information that we're getting. Second, the scale indicates the data summarization techniques or the statistical analysis that are possible or are useful to us. It also indicates that. Let's go into the statistical analysis or the data summarization techniques now. Okay, the first thing is, usually for qualitative or categorical data, we use frequency distribution for data summarization. Data summarization is basically we are summarizing the complete range of data that we have. A data might be like thousands of lines in an Excel sheet, but we have to summarize it into a small point, and we can make a story out of it or an insight out of it, right? How do we summarize it? We summarize it using frequency distribution. Perfect. Now let's look at examples. The first example is Google Play Store rating on a mobile app. So for example, on a Play Store, on a particular hypothetical Play Store, there are 4 categories of rating that a person can give: very good, good, bad, and very bad, indicated respectively by V, G, B, and X. Okay. Now the data, let us say that for a particular app, we have 225 very goods, we have 73 goods, we have 34 bad reviews, and we have 36 very bad reviews. Okay. From here we can understand, okay, there's 61% of very good, there's 19.8% of good, and so on. Then we can go into the graphical representations, which is pie charts and bar graphs. These are the two that are most important for this kind of data. Okay, so pay attention to this, because it took me a lot of time to internalize this as well. You'll internalize this too. Just a side note, if you're looking for these notes, it's down in the description, you can find that there. Now the next thing is example 2, which is visits or traffic to the Amazon website. There are obviously 2 kinds of traffics. One is direct, one is indirect, right? Indirect can be of many types. For example, somebody sends a link over WhatsApp, and from WhatsApp somebody goes to Amazon.in, but that's all indirect. Somebody goes to Facebook and then goes to Amazon, all indirect. Okay, since the others are just indirect, we can term it as others, and we can see how much they are. So for example, the data shows its direct is 122 visits, indirect is 156 visits. This is an example data. Now here it's very similar to the first data, right? We can also create a pie chart for this. We can also create a bar graph for this. So basically, to understand what we have to summarize from this or understand from this is, for qualitative or categorical data, how do we find a data summary for it, or how do we summarize it? It's through frequency distribution. How do we do that? Through 2 kinds of graphs, pie chart and bar graph. And the frequency distribution entails in itself that we have to look at the frequency of the basic categories. That's all in qualitative analysis. Now we can go to quantitative. Usually for quantitative or numerical data, we use interval based frequency distribution for data summarization. Interval-based frequency distribution is also known as grouped frequency distribution, which means that we're looking at intervals. Let's take an example to understand this. The example is based on average size in MBs of each song. Let's say Apple, the company, in a lot of years back, they have to decide what size of iPod they need to manufacture. Now, for them to understand that, they have to do a particular analysis, which is this kind. Let's say the data looks like something like this, where the song is S1, S2, S3. There are different songs. I've just named it randomly, but they have different sizes. Okay. Now, the graph that we make here is a histogram, and in this graph, we are basically looking at how many number of songs have their sizes between 0 and 1 MB. Then how many number of songs have their sizes between 1 and 2 MB, and so on. That is how we look at a histogram and look at the frequency on the x-axis, right? Frequency on the y-axis, I'm sorry. X-axis is intervals or size. Now, from this, by looking at this, Apple can recognize that, okay, it looks like most number of songs will be covered if we make a particular iPod with size per song of 3 MB. Let's say we have one person can have 100 songs in one iPod, that will make 300 MB, right? So they can manufacture a product or an iPod with 300 MB of storage and claim that it's made for 100 songs, for a person to record and listen to 100 songs. Perfect, makes sense? Let's go to the next thing, which is two other different kinds of data. One is cross-sectional data, other is time series data. Let's look at that. First one is cross-sectional data. This is data that is captured in a particular time frame, right? So this is the flow of time. It goes in one direction. We isolate a particular amount of time interval related to the context, whatever context is there. Based on that, we take a particular time interval, and then we say that, okay, what is the data in that particular time interval? Let's look at the example to understand this better. The example is selling price of houses in a particular month. Now this will change in the next month. Next month, the price of the houses may change, but this month, this is the data. Okay, makes sense? In a particular time interval, we have taken this particular amount of data, and that is what we are using for analysis. Okay, so that's one. That's called cross-sectional data because it's a cross-section of different time intervals. Now, come to time series data, which is just the continuous form of this. Continuous is data that is captured in multiple time frames, and this is called the time series data. Now, in this, for example, it is sales of computers from 1990 to 2024. If there's a data set for that, that will be a continuous format of data where we have recorded the sales in multiple time intervals, multiple years. The second thing is stock market price for a period of time for Nifty 50, for example, in the Indian stock market. So again, that is a continuous thing. We can look at, for example, in context, the time period is 1 month or 1 day, for example. We can look at the stock price every single day and it changes, right? So it's a continuous graph for this. So that is called time series data. This kind of data is generally used for predicting or forecasting the future. We all know how stock market enthusiasts and people look at the different trends, etc. That is exactly what happens with this kind of data. We look at trends. Sometimes though, what happens is that trend breaks, and that break of trend is called a structural break. And this structural break is when we can say that, or this structural break is basically the con of this kind of data, that we don't quite can predict what happens in the future. We can sort of say that this may happen with a typically high probability, but we don't know. There can be a structural break and something totally different can happen. Okay. Now let's go into data collections, and this is extremely important, which is how data is collected. It's very interesting. There are two kinds of ways to collect data. One is experimental, the other is observational. What's the difference? People will say that, okay, only when we experiment can we observe, etc. Right? So it's not like that. Let's look at what it is. Experimental is, in experimental studies, the factors or parameters of interest are first identified. And then we go into the experiment and say that, okay, let us keep these two variables constant and let us look at what happens when we change the other two variables to the final response. Okay, that's called an experiment. We know the areas of interest, we know the factors that we're going to tweak, right? It differs from observational kind of data collection, by saying that, okay, in observations, one cannot have control over the factors of interest. That's the most important part here, and the data are observed as they exist. So we are not going into it with any assumptions that these are the data points that will affect the final reasoning. We're not going into this experiment with any assumptions. So that's called observational. What's the pro of experimental data? Because one might argue that only with observational data can we have a very unbiased data, because who knows, there might be one small factor that might be affecting the final result, but we might not know it, and we will only know it when we look at the observational data. One might argue that, right? The benefit of experimental data, as I understood, is that it is relevant for causality, right? It is relevant for causality. Now what do I mean? I mean that when we have to look at how does one particular variable and its change affect a different variable or the outcome, that is where experimental data can function. With observations, we have no control over which variable gives what output. With experiment, we have control. We can say that, okay, let's just keep this constant, tweak this up, tweak that down, and let's see what's the result. So we have causality. We can understand what's the relation of X with Y in experimental data. So this is all that we have learned in the third lecture. It was extremely difficult, let me tell you. If you go through the lecture, you'll understand what I'm talking about. You'll get fed up. But over here, we have completed this in such a short amount of time. That was all for this video. We'll come back tomorrow. I'll learn more and come back tomorrow with the further lectures. Namaskaram. See you again.